Okay, so some of you have asked for the second review sheet to be put up, and I know in class I said no, but I did change my mind. So let's take a look at this first one. This first problem about the ages of presidents when they're inaugurated has only one list. So when I use my calculator, and of course we have to always clear our lists, I am only using list one. There's no frequency on this. Now, this can happen. We had started out this unit with only single lists, and a lot of you are concentrating so much on double lists with the frequency that I think some of you are forgetting about when there's only one list, you're only in list one, and when you go into variable statistics, you don't have to have a frequency. So make sure that you put your data in accurately, like I always say. And I'm almost done. Final grade is age is 46. And now again, double check always to make sure that it's working. And I put 52 in twice. So obviously that's a mess up. I have to clear that one out. And let me go delete that. Okay, so now let's see if I'm right now. I have 46, 64, 69, 52, 61, 56, 55, 43, 62, 60. Okay, so now I know I'm right. So I'll hit stat, variable, calculate, and then variable statistics, nothing else. I don't have to hit list 1 or list 2. So here I find that my average is 56.8. So let's grab the pen and let's write that down. So 56.8 is the average, the standard deviation. Okay, so the next thing is the standard deviation to the nearest integer. Remember, that's the O, and they're telling me on this one to round to the nearest hundredth. So that means that I am going to be using 7.68. Now, to get to the variance, remember, standard deviation is the square root of the variance, so the variance is the square of the standard deviation. So when I square 7.68, I get 59 to the nearest integer. Now, here's where I'm going to need to go up to my normal curve. When my average is at 58.6, and my standard deviation is 7.68, I find that my first deviation is going to be 56.8 plus 7.68. And that gives me 64.48, which I will put right here. Now, next I have to take my average, my 56.8, and I have to subtract 7.68. That gives me one standard deviation below the mean, 49.12. I have to put right here. So this now would be the boundary, one standard deviation from the mean. So at this time, I have to go back to my chart and I have to say, well, how many presidents were over 49 when they were elected? And so that's not Bill Clinton. It would be George W. Bush. It would not be Ronald Reagan. It would be Jimmy Carter. It would be Gerald Ford. It would be Richard Nixon, Lyndon Baines Johnson. It would not be John F. Kennedy. It would be Dwight Eisenhower and Harry Truman. 1, 2, 3, 4, 5, 6, 7. So that gives me 7 presidents fell within one standard deviation. What percent of these presidents? Well, that's 7 out of the 10. And so that's going to equal 70%. Is John F. Kennedy an outlier? No. He's not an outlier because his age is not very far away from the ages of the other presidents. As a matter of fact, his age was pretty close to Bill Clinton's. So he's not an outlier. Now the second page, we're still using the normal curve. So this is when I told you in class, if you have a pencil, you should write right on your curve, and then you can always erase it, and then you can use it again later. So what I'm going to do now is I'm just going to bring a normal curve onto both of these problems so that we can label. It says you have 650 scores and the mean is 154. So that means here at 0 I have to write my 154. Since my standard deviation is 3, over here at 1 standard deviation, that gives me 157. And then at 2 deviations, that gives me 160. Now if I go backwards and I subtract 4, I get 151 at the average minus the standard deviation, and then I get 148. The question is asking me now to find how many people are between the range of 148, which is here, and 157, which is here. So what I have to do is I have to add up these percents. So now I'm going to use my calculator, and I'm going to add up these percents. I have 4.4, I have 9.2, 15, 19.1, plus 15. And that gives me 81.8%. So 81.8% as a decimal would be 0.181, and I want to find that percent of 650, so I'm going to times that by 650, and that is going to give me 532 students. So the answer to this one, 532 students would have gotten a score between 148 and 157. Now the next one, it says that 68.2% of the scores lie between 111 and 129. So now I got to kind of figure out, where am I if 68.2% are between 111 and 129? That's going to be 1 standard deviation each way. So I'm just going to move this up so I don't cover up the next problem. So that's going to put me here. 111 at the -1 is going to put me at 129 here. That's 2 standard deviations because I went 1 to the left and 1 to the right. So if I want to find out what 1 standard deviation is, the first thing I have to do is subtract 111 from 129. And that's going to give me 18. Divide that by 2. And each standard deviation is 9. So my standard deviation equals 9. The next problem is a regression problem. This one is asking me for an exponential regression equation, so I have to be really, really careful that I go to the right place on my calculator. So I've already used my lists on problem number 1, and so now I have to make sure I hit second memory 4. I clear my lists. I go into edit, and on list 1, let's get 0, 1, 3, 4, and 6 put in. And then on list 2, we have 1,000, 610, 220, 132, and finally 45. You're never wasting time by checking your lists to make sure you typed everything in right. And now when I go to calculate, I'm going down to the exponential regression. And here, this is the line where if you have a new calculator, you would get X, Y, and you would get frequency before you get the word calculate. The older ones don't have that. If you have it, make sure you have nothing on frequency. Now it told me to round to the nearest 10,000th, which is 4 decimal places, so I better look at the 4 behind the 9. And when I write my equation will look like 1018.2839. Okay, that's to the nearest 10,000th. I am timesing this by 0.5969, and my variable is up here. So that's the first part. The second part, now I want to take that same equation and I want to put 8 in for x. So I'm going to cheat a little here, and I'm going to use the cloning feature. And I am going to then put the 8 up here and hit enter on my calculator, and I get 16.408,977, and it goes on for a longer time. So here you would say you either have 16 coins, or sometimes you want to say I have 0.4 of a coin, I went beyond a coin, or I have 17. So I think I would probably take either one of those for this problem. Now this next problem, you again have to use your calculator. You have to clear your lists. Pay really close attention. They are letting you know that you had better not use 1999. 1999 is representing time 0. This is time 1, time 2, time 3. So when you type this in, you clear your lists, you type this in, and you go to linear regression. Now I'm not going to do this whole one because it took the time on the other one, but make sure you go to number 4, this line regression, to get your answer. And when you do, you will get y is equal to negative 35.5 x plus 457.5. Now, the next projected cases for the year 2009. Well, notice up here, every year 2002 was represented by 2, 2002 represented by 3. So 2009 means that my x should go in as 10. So if I take this 10 and I plug it into this equation, I am going to get, to the nearest whole number, 103 new cases. So I hope that helped you with the first part on statistics, and there'll be a second part on the sequences and series.